Pneumatics is a technology where the air is compressed by a compressor. This compressed air is stored and then sent to the pneumatic circuit. Let us understand in this video what are basic components of pneumatic systems and also understand the technology behind compression of air. Let us begin first with understanding how do we categorize the components in a pneumatic system. If you look at overall the components which are there in any pneumatic circuit, we can categorize them in four categories. Number one, compressed air generation. Number two, compressed air treatment. Number three, compressed air distribution. And then finally, circuits and applications. Let us understand what are all those things which are involved into each subcategory. First, when we look at compressed air generation, it basically talks about the compressor. Compressor is a device which is used for compressing the air, that is increasing its pressure. And next, after compression, we require to treat the air. What is air treatment? Air treatment is all about removing the water contents, removing the dust particles, maintaining the pressure and ensure that the air is ready along with the lubricating material added to it and the air goes into a circuit. What are those things which are involved into distribution system? In case of compressed air distribution, basically we need pipes, hoses, connectors and elbows. And when we say about applications, applications are all about circuits wherein there are actuators like pneumatic motors and pneumatic cylinders. Let us begin with now a compressor. Compressor is a very important element in any pneumatic system. It compresses the air. When we say compresses the air, then there are two things which are very important. Number one, it reduces the volume of air, and number two, it increases the pressure of air, reducing the volume and increasing the pressure. That is the basic task of a compressor. When we look at compressor, it looks like something like this. Let's look at what are the components which are there in this particular compressor. First, we have a reservoir. A reservoir is something looking like a tank and it forms the basis on which the other components are mounted. The reservoir in this case is a horizontal reservoir and it is mounted on a floor by using supporting legs. At the bottom we can say there is a water drain. Looks something different. We're talking about water in a compressed air system. True. When we compress the air, then the water particles separate out. But from where the water is present in the air? Water is present in the air in the form of moisture contents, and those small water contents are denser, heavier than the air molecules. When we compress, then the water particles separate out and the water gets accumulated at the bottom of a reservoir. This water is required to be removed, and for that purpose this water drain is present. Let us look at now the outlet. The outlet is present from where the air goes into circuit. If you look at the compressor, then it consists of multiple stages of compressor. What is a stage? A stage is something where there is a cylinder and there is a piston. Air comes in, air is compressed, and then it goes into next stage where that compressed air is further compressed. So we have a stage 1 over here, stage 2. Stage 1, we compress the air, the pressure increases, but we still would like to increase the pressure to our expected level. So this compressed air is further compressed into stage number 2. These two stages are normally mounted on a single crankshaft. A crankshaft is a shaft on which the two pistons are connected. And in this case, this crankshaft is driven by an electrical motor. For starting the motor, we have a motor starter which ensures that the motor can be started and stopped as per our will. And when the air is taken in, the air consists of some dust particles. We require to remove them before the air enters into stage 1. So for that purpose, we have air filter which is present at stage number 1 at inlet. This compressed air, when it is stored into a reservoir, we also require to find out what is the pressure in this reservoir. For that purpose, the pressure gauge is fitted. And along with that, there is a pressure switch, a pressure gauge and a pressure switch. Pressure gauge is required for visual appearance of a pressure inside the reservoir, whereas pressure switch is a device which senses the pressure and at the same time it ensures that when the pressure is reached, the electrical supply to the motor is cut off. So for switching off the electrical motor, the pressure switch is used. Let us understand the working of a two-stage reciprocating air compressor. I said reciprocating. There are various types of compressors which are used in industry and majority of them are reciprocating air compressors. Let us look at the working of it, and for that purpose we need to understand different elements first. If you look at this reciprocating air compressor which consists of two stages, we see over here that there is a first stage cylinder and there is a second stage cylinder. There are two cylinders, first stage and second stage. How does it work? First, the air comes in through air filter. There is an inlet valve for stage number 1. The air comes in into this stage number 1 cylinder. Because the piston moves down, this piston is moving down, and the piston moves down, there's a vacuum which is created on the top of a piston. Over here we see that there is a vacuum created, and because of a vacuum the air comes in. At the same time, there is one more valve which is outlet. The outlet valve remains closed because the physical condition of this valve is exactly opposite to that of inlet valve. The piston goes down and it takes the air inside the cylinder. After half of the rotation of a crankshaft is located over here. As I said that the crankshaft is connecting two pistons. We are talking about the first stage piston. In this case, the air, it is taken in. Now is a stage where the piston starts moving up in the latter part of rotation of a crankshaft. Remember, in one rotation of a crankshaft, for half of it the piston goes down, and for half of the rotation piston goes up. When the piston goes up, this is the inlet valve which goes into a closed condition, and this outlet valve goes into open condition. What is open? It allows that compressed air to pass through it. In this case, the compressed air after stage number 1 compression, it goes out of it and it starts flowing through a pipe, a red colored pipe, and through it goes into second stage. When it enters into second stage, we see that the condition over there is similar to that of the first stage. The difference over here is the air which is receiving in second stage, it is already compressed, whereas we would like to further increase the pressure of this air. What about this intercooler? As the name suggests, cooler, it works like a cooler, yes indeed, but it is working in between two stages. When the air is compressed in first stage, the pressure increases, but at the same time temperature also increases. We need to cool down the air, and for that purpose this intercooler is present. Intercooler is basically a heat exchanger where it dissipates the heat to the surrounding and ensures that the temperature of the air drops down. It also ensures that the overall performance of this compressor gets enhanced because of losing that temperature into surrounding. We need to improve the efficiency. For that purpose, this intercooler is present. Now, when the air is getting compressed into stage number 2, what happens? Let us look at this, that there is an outlet valve and through which the air passes out of this air compressor. This is how the air is getting compressed into two-stage reciprocating air compressor. Remember that the compressor in many of the industries is reciprocating air compressor, and many times it is two-stage reciprocating air compressor. There can be certain situations where the volume of air is more rather than pressure. I said the volume to be displaced is more at a lower pressure. In that case, rather than using a reciprocating air compressor, we use lobe compressor. In case of lobe compressor, there are two lobes. We can see lobe number 1 over here, lobe number 2. This is the inlet from where the air comes in, and when the lobe rotates, then the air pockets are formed over here, and these air pockets are transferred into outlet. This is outlet. Air pockets are getting trapped and those air pockets are getting transferred. When we look at the lobes, then there can be 2 lobes or there can be 3 lobes. Let us understand the working of a lobe compressor by looking at one of the animation. This is a 3-lobe type of compressor in which the air is taken in now from the left hand side. The arrows are indicating the movement of air. The air is getting trapped and then getting displaced on the right hand side. This is how the air is getting displaced and at the same time getting compressed by using a lobe compressor. In this video, we have seen what are different types of elements in any pneumatic system, and also we have seen the working of compressors, especially two-stage reciprocating air compressor and lobe compressor. So next time whenever you get a chance to visit any pneumatic system, do have a look at the compressors. Identify the type of compressor and do identify the multiple stages which are present in any compressor.